Hi everyone, it's Alex here. I'm developer advocate at Elastic, and today we are talking about RAG architecture. So our journey today begins with this paper you see on the screen, titled Retrieval Augmented Generation for Knowledge-Intensive NLP Tasks. This is the very document that introduces the world of RAG architecture, published by brilliant minds of Face AI Research. This groundbreaking paper harmoniously merged retrieval-based and generative models, paving a new path for the knowledge-intensive task in natural language processing. It's be the blueprint for concepts we'll be delivering it today. So this is the RAG architecture. RAG means retrieve augmented generated. Imagine that you have a large jigsaw puzzle and you need to find the right place to complete it. RAG stands for Retrieve Augmented Generate, as I said. It's like a helper robot that does three things to assist you. Retrieve, first it quickly search through the puzzle piece. It knows to find ones that might fit. Augment, after pick out some pieces that seem right, it examines them more closely to understand which one is the best. At the end of this pipeline, it gives you the perfect piece and sometimes even suggests how to fit in the best puzzle. So RAG is like a super helper that assists you in solving problems, answers questions, and completing tasks quickly using all the information it knows. And you know that you have a lot of large language models in the market. The big techs are launching their all LLM models. That's a big transformations in AI area. And the LLM had a lot of advances like a big learning base, a real-time interaction, but also has some limitations. For example, hallucination, not updated in real time. So how do you deal with these advantages and limitations to create a better architecture to to improve our productive use of this kind of model? Do you know that LLMs are powerful tools, but you should use with discernment to not according with this kind of limitations. And you have a main element between this architecture that we name embeddings. That's vector representations of word, phrase, video, images, as you said before, in a semantics and multidimensional space. For example, here we have a 3D representation of some words, and you can see that semantic words are plotted together in different dimensions. Remember that inside Elasticsearch you had the dense vector with 2048 dimensions. So with the embeddings, you can quickly compare semantics and we can enhance our context and semantic understanding. We can allow RAG to scale to vast database and keep with updated information and so on. So back again to the RAG architecture, we have our LLM with pre-trained data from a lot of large database like web, wiki, books, etc. And the other side, you have our users that would like to perform some query inside the LLM model, but to avoid some limitations like hallucinations and and updated information, you need to put a specific data set between them. So we'll create some vector search and use an embedded model to translate for a specific tasks. And you have a kind of database here has Elasticsearch ingesting data from different sources like PDF, like web, like relational database, docs, image, and putting together inside our vector database. After search using semantic search, we retrieve the relevant information in a context window. So now we can ask for LLM model like ChatGPT, like Llama 2, like Bard, with more relevant and context information. So we will have the response to our system and back to the user. Using this architecture, we will avoid the limitations of LLM models and improve with updated and semantic information from a vector DB. For example, if I ask it today for a ChatGPT, what's the Neymar actual team? I will have the response from September 2021 that Neymar was playing for Paris Saint-Germain. But now, if I ask the same question using RAG architecture in our example, the response update will be according to the information provided to the week doc, Neymar's current team is Al Hilal. So making a recap, bridging the gap between RAG, bridging the gap between the vast information repository and intelligent language generation. They proposes to combine the strengths of retrieval-based and generative models for more informed and accurate response. In the retrieval phase, search a large database or corpus to find the most relevant passages or documents, often powered by vector DBs and embeddings for fast semantic-based matches. And the augment and generate phase uses the retrieved passage to provide the context. And the LLM model then generates a current and contextually relevant answers. So it's that for now, and we have the next chapter of the next episode. I think 2 episodes of videos trying to create example programming in Python about using this architecture and implement it in a real approach using LangChain, Elasticsearch, and so on. So thanks for watching.